Okay, so we are at the verge of the end of the third unit, that is a modulator, demodulator, and the PLL. So modulator, demodulator, that part we have covered, and we have started the PLL part. So in that the PLL part, today we are going to focus on this particular the in detail. Already in brief we have gone through, but today we will see that exactly how this the block diagram and it's a working for FM detection, FSK detection, and the PSK detection. So for that, as I told in the last session also, that you should know the brief introduction about this, the concepts of FM detection, FSK, and the PSK. So we will have a look today also. So this is what we have gone through, that is related to the PLL. What is PLL? Which IC is available in the market for PLL? What is the internal structure of this PLL? The different formulas for the calculation of the different frequencies in the PLL. And one problem also it was given, or we discussed actually here. So how many of you have solved this problem? I am not sure about, but you're supposed to solve that and get it checked by me also. Okay, so these are the formulas only we have discussed over here, but how many of you has put the values and calculated and got the values for this one? I don't know. So just if you have calculated, so keep in the notebook. So whenever you will be here, so you can show it to me. After that, we have gone through for the applications of the PLL. So different, so many applications are there. They are interlinked with each other. But as a part of the 1, 2, 3, 4, the number of applications. So these are the few of the applications mentioned for the PLL. So that is the synchronization and the demodulation, and clock recovery, noise and jitter reduction, frequency synthesizer, and the microprocessor. So in that we are going to focus in this syllabus, that is the demodulation circuit and frequency synthesizer. These two are, it is mentioned in the syllabus, so we will just concentrate on that only. So the first of all, this is the first application from that, that is the FM demodulation using PLL. So for that, first we should know that key, what is the FM. So I will, instead of just making here, I will add. So what is the meaning of FM? That I want to from your side. So that what exactly it is happening in FM. And then I will tell that how through by using the PLL, it is possible to get the demodulation. So anyone from online student? What is this concept of FM? Then FM demodulation. And then by using PLL, how we can achieve our target like that. Take 1-2 minutes, construct the definition or the explanation for the same and tell me. Because if you are not remembering the concept of FM, so there is no use of just explaining the whatever the all other I'm going to explain over here. Can anyone? So it seems that no one is knowing. So it's a very new concept for you. Okay, no issue. I will do my work. You do your work. So from offline student, can anyone? Hmm? That is okay. That it is a frequency modulation. But what exactly is happening of frequency of carrier is going to vary in accordance with the input modulating signal. But modulating signal is having the three parameters, as we know, that is the amplitude, frequency, and phase. So according to modulating signal means which parameter it is going to have a this change. That is important. So it will be the amplitude. So amplitude of modulating signal, not the frequency. So if you will see here, so the FM output is look like, so somewhere it is having the high frequency and somewhere it is having the low frequency like that. So compression and the rarefaction, that is the concept of in this particular the FM. So where we got this compression and where we got this rarefaction, so that also we should know. So that is the base of just detection. That is the opposite process in the demodulation. So when this compression is going to be happen for the positive half cycle of the modulating signal. So that is going to be happen. If the amplitude of modulating signal is gets increased, so it is going to be compressed more. And if the for the negative half cycle of that the modulating signal, so it will goes on the diffract from each other. So this is what the FM signal is. Now the opposite is going to be happen at a detection, that is at a receiver level. So how it is going to be happen, that where this particular compression is there, so there it will get the positive half cycle, and where the refraction is there, so it will convert into the negative half cycle, and the both adding to this one, so it will be your original modulating signal. But before that, how much the carrier you have introduced at transmitter level, that also you supposed to be find out. And for that, two methods are there as we discussed. That is, one is the coherent and another is the non-coherent. So in coherent, whatever the carrier signal is used at transmitter, the same signal we supposed to use at a receiver signal to extract the carrier signal. So that is what the concept of this FM demodulation is here. Now, as you can see the diagram in front of you, so this is the setup for FM demodulation using the PLL. So I am requesting just to draw this, give the heading, put today's date and draw this diagram. So the PLL here it is been used, it is a LM565. So give the title, put today's date and draw this block diagram of the setup. So here the pin numbers are very important, because as we have seen the internal structure of this 565, so we're supposed to compare with that. So if that internal structure you have drawn in the notebook, so definitely you can just put these both the diagrams in front of each other and you can compare. Is it over? Online students, you are also has to draw this diagram, because when you will report here, so definitely I will check the notebooks. So be ready with that. Now here one point has to be note, that is about this VCC plus VCC and the minus VCC. So as this 565, it can be operated during the range particular, that is from plus 5 volt to plus 12 volt, plus minus both. So if you are taking the plus 5 volt, so the minus you supposed to take the same, that is minus 5 volt, like that. So that you can observe over here. If you want to take the plus 10 volt, no issue. So but for that the negative 10 volt also it has to take, for the synchronization purpose only. This is the, so if you are over, so this is the diagram what I was expecting, that have you drawn this one diagram in the notebook, because here the pin number 2, 3, 4, 5, 6, 7, 8, 9, 10. So they are the here, and accordingly the only the few modification has to be done in the this particular diagram, and you will get the FM demodulation as a output. So as we discussed here, this 4 and 5 has to be short. If that time you are remembering, R1 and C1 combination, what it gives? It gives for the VCO, that is the free running frequency, can be identified with this the combination of R1 and C1. What is this R2 and C2? It is forming here, the three blocks were there. So one VCO, R1, C1, and it is R2, C2. This is what here it is, the this combination is forming the LPF, that is the low pass filter, and the third is phase detector, and phase detector is here. So like this, three blocks are there internally in the PLL, and we have just modified that the respective block diagram. And amplifier, it is the in a combination of this particular LPF. Don't forget about that. Sir, we have not drawn the amplifier, but it is the additionally part, not mandatory, but it is necessary. Get the wording, not mandatory, but it is compulsory over there, because whatever the output you are getting of this phase detector, that is in a small voltage, millivolt. So to get it amplify, this particular amplifier is going to be utilized, and then after it passed to the LPF, and the next at 7, pin number 7, you will get the output. This is what here two inputs you can see for phase detector. So these are nothing but this the particular two inputs are here. So if you are now comparing right now whatever the diagram we have drawn over here, so the FM output instead of that FM input over here, FM input is given at pin number 2. So this is the receiver side, whatever the diagram is there. So it is at a receiver side, and in PLL pin number 2 it is provided, that is with the FM input. FM input means this one is provided over here. Pin number 3, it is getting the grounded only, which is used as a reference input. Ground means 0. Ground means 0. So when there is no input, this one is also 0, this one is also 0, and the final output, that is the demodulation, it will be also the 0. This is the basic concept, or the by default at the start this is the situation. But the second step is that you're supposed to manage, or you're supposed to choose the internal R1 and C1. So R1 and C1 is at what pin? They have given the nominations over here, R1 and C1. These two components we supposed to select in such a way that the VCO will start oscillating. This is the second step. So how to choose this R1 value and a C1 value? So it depends on that, the whatever the FM input we are passing to it. So if the problem statement it is there, so this FM input it is been applied to this PLL. So the VCO frequency should be near to that. It is near to that FM input or exactly the same as that of the FM input. Then you will see then what is the use of the PLL. If we are just generating the same frequency by using this VCO and input is also the same, what is the use of then PLL? So PLL's main use is to fix or to make constant the output. Because if input frequency changes, if due to some reason, it may be your thermal conductivity or due to some internal component resistivity, if the this FM input is getting changed, there should not be any effect on the output. That should remain constant. So that's why this PLL is going to be used. So how this PLL is going to be work? It is in working in a locking phase. Locking phase means what? If both the frequencies are same, if input changes, output is also going to change. If input decreases, output also getting decreases. Means the phase difference will remain same. Get it? The phase difference is going to remain same. Even though the input frequency is of 10 hertz and your VCO frequency is of 100 hertz. But if the phase is same, that means the output is going to be constant and it is not going to hamper. Even though if this 10 hertz is there input frequency, but it becomes due to 11 9 11 9, but here it is going to be remain same, that is 100 100 100 in that accordingly. So this is what how it is going to manage the constant output of this particular the PLL. So that is the main function of PLL. And now how it is going to be used as a FM demodulation. So FM demodulation is nothing but there are two steps. That is, first is the how much carrier you have added, that you have to remove it. And as it is the FM, so again you supposed to get at the output, that is at pin number 7, that is the modulating signal, original modulating signal. That means the plus minus plus minus. So how it will getting that plus minus? So it depends on here. As you only told, the compression means the plus and the rarefaction means the minus one. So it has to detect that. How it detects plus minus? It is for our sake. How that circuit is going to identify? So it identifies the frequency. If large frequency, it takes a positive envelope. If the less frequency, it will take as a negative envelope for that. And it is going to construct this particular the output. So this is how it is there. So I want to just show the description also for it. Okay, how exactly the step by step it is given over here. Where is that? Frequency synthesizer. I also taken from the internet only. So as the language is a easy one, so I took this same FM detector. I hope it is visible to all of you. So, okay. So FM detection, there is a shift in carrier frequency about mean value, because the carrier, as we discussed about the concept of FM, the carrier frequency is having its own frequency.
Rahul. Rahul Rajput. What are you doing?
बोल क्या अमर.
What are you doing?
काय?
अरे काय दोघ
फवारायला
जण
चालू
जॉईन झाले
फवारायला.
आपण. लेक्चर आहे का नाही कोणाचं आहे?
अरे लाईटचा प्रॉब्लेम होता, मी जॉईन करून फवारत बसलोय, मका फवारतोय.
बर बर. अरे नाही नाही लिहू, दुसरा लेक्चर चालू झाला आता होतंय.
11-18 झाले त्या पहिलंच लेक्चर आपण जॉईन करल्या अजून.
मग काय तर जायला. कुठं आहे मका? बघू दाखव.
बघ
डेंजर
दिसतंय का?
काम करतोय हा? होय होय. खतरनाक काम करतोय दादा.
करावं लागतंय.
मग काय जरा घरी असल्यावर काय विषयच नाही.
हा
भारी आलं हिला, चांगलं झालं हिरवगारा.
पाणी असल्या पाय.
चालतंय चालतंय. कर कर काम कर.
होय होय ठेव.